Julie, what a pleasure to be here with you.
John, it's wonderful to be here with you as well.
So I am John Vukich. I'm a general ophthalmologist located out of Madison, Wisconsin, and do primarily cataract and cataract refractive surgery. And that has been a main focus of my career in developing different lenses, new techniques and technologies, and I have a lot of experience with working with different types of lenses.
And I've learned so much from this man over the years. My name is Julie Schallhorn. I'm at the University of California, San Francisco. I do cataract, cornea, and refractive surgery. A major focus of my research is really on patient satisfaction and patient-reported outcomes after cataract and refractive surgery. So happy to be here today.
Ah, wonderful. Thank you, Julie. So I think one of the things I'd like to kind of explore and maybe learn a little bit about, or maybe to share some experiences of the different types of IOL materials. We know that there's more than one type of material. There's acrylic, there's hydrophilic and hydrophobic, there's silicone, and there's collamer. And so maybe we can address some of the pros and cons and why we choose what we choose, and maybe what are the advantages or maybe some of the challenges that some of these materials face.
Yeah, definitely. It's a really good thing. It's always so important to really know and understand what you're working with and what you're putting into a patient's eye. I think you really owe it to your patients to do that.
So in the United States, acrylic is probably the predominant type of material. And we know there's two different types. There's hydrophilic and hydrophobic. And maybe you just want to touch a little bit upon, obviously they're self-explanatory, but what are the differences in the materials and why would we choose one versus the other?
Yeah, the major difference is really in the manufacturing process and whether or not the lens incorporates water into the material, hydrophilic, or excludes water from the material, hydrophobic. And they perform a little bit differently in the eye. And I would say in the United States right now, there are these two options, but probably the predominant one is really hydrophobic. And that's for the major reason that there can be issues with opacification of the hydrophilic lenses with that material over time.
So we've seen that, and we've seen that with some of the sutured implants where typically post-vitrectomy or other surgical procedures where that actually precipitates some opacities in the lens in the hydrophilic lenses. And I think for that reason, it's been somewhat of a challenge for the major companies who use that material in the United States. But we've not seen that in Europe. I know it's one of the most common in Europe.
Yeah, it really is. So I'm gonna, one of the major lens manufacturers in Europe, the majority of their European platform is actually hydrophilic material, and they seem to not have that opacification problem. It may be though, we see that most commonly in the U.S. here with either a scleral fixated hydrophilic IOL. There's a 4-eyelet scleral fixated IOL that was very, very popular for a time to do that fixation with, and hydrophilic material, when you expose it to air or gas, it's hydrophilic. It has to live underwater all the time. When you expose it to air or gas, you cause this reaction where calcium then precipitates inside the lens. That happened in Europe when you have an aphakic patient. They tend to use the iris claw IOL rather than scleral fixating that. So that may be why they have not seen that material, that issue uniquely over there. Although you can still see, even in absence of in some IOLs, even in the absence of an exposure to a gas or an air bubble, you can still see opacification. There was actually a huge issue with that from one manufacturer in Europe that has now gone out of business. Those were the Oculentis lenses.
Right, and that was a major problem.
It really was.
Well, I was unaware that the iris claw lens, it's a model of lens where you actually take the iris and it goes between the pincers of the implant, which on the face of it, I think just never caught on in America. And even though it's actually, they are approved, and you can use them as a phakic IOL.
It was a great phakic IOL for the time until the collamer lens came along.
Well, so even the hydrophobic acrylic lenses, there have been some challenges with those as well.
Yeah.
Maybe just kind of touch on that a little bit.
Yeah, and that really maintains to the manufacturing process. And like I said, hydrophobic lenses really need to exclude all water from them. If you have water in them, they can form these vacuoles. The water inside the lens material can, over time, form these vacuoles inside the lenses, which we know as glistenings. And there's this perpetual debate over whether or not glistenings are visually significant or not. And some manufacturers have said absolutely not. Doesn't matter how many glistenings you have. They have got some studies to show it. And then when I look into an eye that has a lens put in 30 years ago that's prone to glistenings, you look with a slit beam, and it's like looking through a cloud. It's like looking through a foggy day. I don't know where you stand on that.
It is not uncommon where patients who are back into the optometric care for routine care, and they'll be sent in for their second capsulotomy, when in fact they don't have a posterior capsule opacification. It's the glistenings that are showing up. And so it is an issue. Now, I would say that it really has to be extreme before you start to see a visual significance. And the patients really don't see it. They don't report visual symptoms as a result, even though we look at it and go, oh my goodness, that doesn't look right.
And part of me wonders, because you are not changing the refractive index, you're not changing anything on the surface of the lens, so that makes sense. But then part of me also wonders, because it's a really slow process that these glistenings accumulate. It's like how, when you get a cataract, it's like an extremely slow process. Some people, end up with like, especially those really slow-growing nuclear sclerotic cataracts in there. You look at it and you're just like, how are you seeing out of this? How are you seeing through this cataract? And they're like, you take it out, and the next day they're like, oh my gosh, I had no idea that was there. I see so much better now. So I don't know.
I tell patients it's a bit like painting your house. There'll be a point at which the neighbors think it could use a little freshening up. And when you finally get to it, you don't paint just half of it, right? Because you're going to see the difference now. But there is that. So what would be like a specific instances in which you would choose one material over the other? I don't usually, just because, and I've got like a complex population of patients that, have Fuchs. They may need endothelial keratoplasty in the future. We've got like a high referral basis from my retina colleagues who may have a repeat, detachment. I tend to not put in the hydrophilic lenses. How about silicone? We haven't even touched on silicone yet.
Yeah, silicone. Okay. I know. John, this is gonna. Silicone had really, I think, fallen out of favor, except for like a piggyback IOL until the adjustable lens came on the market, which is a silicone lens. That is actually the first silicone lens I ever put in. I had never put in another silicone lens.
Okay.
But it's cool. The silicone lens material it injects a little bit differently. It doesn't have that slow unfurling that our acrylic materials have. It just kind of like springs open when you put it into the eye. But the great thing about silicone is that it's malleable, and so when you combine it with the adjustable lens with the macromirrors, you can shift the shape of that lens, which is pretty cool.
There's no question. So I have become a convert to silicone as well, and I like maybe following trends, but also following some of the other issues where I thought, what is the best material? The light adjustable lens does address that, but there's a higher rate of PCO. And that's always been the downside to silicone. So we know how to treat that, right? We know we can use a YAG laser, but it's going to be a more common secondary procedure. And it's hard for me to know, yes, the silicone promotes that, but also when you start having an adjusted lens that has a very high level of acuity, if you're at 20/15, there's only one way you're going to go,
exactly.
Right? And they start noticing the 20/20 change, and it's the capsule that does that.
Yeah, exactly.
How about 3-piece versus 1-piece?
That's a good question. I think that, I think as a surgeon, you have to be comfortable with all types of lenses, because there are few specific instances where you really need to know how to use a 3-piece.
Right.
And that is incredibly important. Obviously, it does require more finesse to inject the 3-piece, because you have to get the haptics in the wrong way. All of our 3-piece lenses are volted, meaning that the haptics are angulated away from the body of the optic. They're usually angulated anteriorly, but if you put in a 3-piece upside down, it means the optic is angulated anteriorly, and that can cause two problems. You're not in the same lens position, so you have a refractive shift. B, you can actually volt that lens anteriorly and cause pretty bad UGG with a 3-piece IOL if you put in a 3-piece upside down in the sulcus.
So you are one of the best teachers that I've ever met. You are so skilled in the OR, and I've seen you work with residents. Do you teach your residents how to use a 3-piece lens?
Absolutely. Because the time where you have to put in a 3-piece, right, is when you have an open posterior capsule. Because you need to have even if you're going to optic capture, which I love doing, if you have an open posterior capsule, but you have to have those nice thin round haptics in the sulcus. You can't leave the square edge haptics of a 1-piece in the sulcus, because that, in a great majority of the time, will chafe the iris and give somebody uveitis, glaucoma, high femur, or UGG syndrome. So I always say to my residents, we're going to put it in 3 pieces in completely normal eyes, just so you get used to how to inject them and feel comfortable with dialing them into the bag, so that when it comes time when you've got an open posterior capsule and you need to, not inject your lens through the posterior capsular rupture or make it worse, you feel comfortable doing it.
Absolutely, and that leading haptic as it comes out, having control over that with an open
Exactly.
capsule, you need to know where it's going.
Exactly
And so
where it's gonna
paying
go.
attention if you're going to get it into the sulcus, you need to know how to at least get it in the bag first, and don't learn your first time under a bad
You
situation.
never want to do that.
Yeah, no, I'm
Yeah.
completely there. And in fact, I teach residents the exact same thing. I think the other thing that residents should know how to do is a small incision extra cap. There are times where we become heroes with our phaco, and quite frankly, patients really better off having an extra cap if they
Exactly.
have that rock hard nucleus.
Yeah.
And those are the other situations in where the choice of the implant can be influenced by that. You
Exactly.
may not have capsule integrity. So, yeah.
Yeah. No, I totally agree with you. And especially about the small incision extra cap as well. Incredibly, incredibly important, I think.
It's one of the mandatory things where patients have to, you have to be able to deliver a quality outcome to the patient, and it's not about the surgeon. It's how the patient
Exactly.
does at the end of the day.
Exactly. So important. So important.
So there's one other material that we didn't touch on. It's collamer. Now, there isn't really an intraocular lens for cataract surgery, but there is for a phakic IOL. And that is something that's been around now for 20 plus years. A technology developed in Russia, brought into the United States, and it is now the material that's used in implantable collamer lenses. And the material itself has been remarkable. I have a great deal of experience with this. And we simply don't see glistenings. It is a material that is not silicone per se, but it has a collamer a component to it. And it's a unique proprietary mix. And I do wish that there was an IOL that they made of it, but they stopped. The company that has this stopped doing it. But again, there's that third material, a fourth material.
That material to me is so fascinating. I love it because it sits with the phakic IOL. It is in contact with the sulcus. It is in contact, if you look at the UBMs, with the iris. The iris is actually sitting on this, and it's totally well tolerated. And I think it's super important, actually, even if you don't put in phakic IOLs, to understand and know about this material, because you're going to have patients, especially with the advent of the central flow phakic IOL.
Yeah.
You're going to have patients that had that coming in for cataract surgery, and you need to know how to deal with it and how to remove it.
Right.
So it's really important to know how to handle that material.
That's absolutely the case. So I think we've covered a lot of the different things that we can use for an implant. And what do you think the future holds? If you put on your Nostradamus hat and say, all right, where are we going to go as a field and as a profession?
It's such a good question. I think we are all, and we've talked about this before, I think we're all really excited about the possibility of having a lens that can actually replicate true accommodation. And that, I think, is going to call for some unique materials, and possibly some unique, lens features that we'll have to get to know about. But I think that we're going to see, I think probably two things. We'll see a continuation of transition of the platforms into ideally glistening free, hydrophobic acrylic. And I think we're going to see probably some interesting materials that come out from the search for the accommodating IOL.
Absolutely. Now, the ones that I am familiar with, and I know that you've been working with the development of this and bringing together the techniques and the things that make this possible and successful, and I've had experience with this as well. Primarily, silicone is a big issue and a big part of that. Both a silicone oil as one of the components of the lens. So here's a whole nother material that's going to show up in our implants. And how soon? Hard to say. But I think that it's, from my perspective, hard to imagine a future in which there isn't an accommodating IOL. And are we there yet? Maybe, but we're getting closer.
We are getting closer, and it is such an exciting time, I think so.
I couldn't agree more. Julie, this has been a great conversation. Thank you for sharing some of your insights, and I think there's so much more that we can learn, but we're learning together, and that's really what makes our profession so fun.
Exactly. Always enjoy talking to you, John. Thank you so much.
Thanks, Julie.